So our language enables us to write these lists of WIFs. Given a number of WIFs, we'll number our lines here, 1, 2, 3, 4, 5, and so on, given some number of WIFs, which we've termed assumptions. Sometimes these are termed premises. Premises, we can then, by application of our inference rule of modus ponens, continue that list, and everything that we then write after the premises have been set out, I've termed consequences. Now, consequences. Now, the consequences flow from the assumptions. Insofar as that is the case, this constitutes, and propositional calculus as we're calling it, constitutes a deductive system. Now, I've got one more definition that I'll just give you. If we have a privileged set of WIFs which act essentially as assumptions which we are able to pull out of the hat, as it were, and write anywhere in a list of WIFs, anywhere in our any deductive chain, as it were, then we will call those privileged WIFs which are assumed to have a truth value of true, to be true, we will call those axioms. And a language, together with a set of axioms plus a language, constitute what we will call a theory, and in particular a logical theory. So that is a definition. Now let's look a little more closely at the ascription of truth values to WIFs. By our formation rules, a sentence letter standing alone, say A is a WIF, and any WIF A may have the truth value of true, or it may have the truth value of false. This is a binary semantics with only true and false, truth or falsity being ascribed to our WIFs. Now, our connectives, these connectives of negation, implication, those are our primitives, conjunction, disjunction, and mutual implication, we say are truth functional. These connectives are truth functional, and they're truth functional in a very obvious sense, as follows. Let us suppose we have a WIF negation A. Well, this connective is truth functional to the extent that if A is true, then negation A, not A as we've described it in English, is intuitively false. And if A itself is ascribed the truth value of falsity, then negation A has the truth value of true. So what this connective acts as is essentially a function. It's a function. In this case, it's a unary connective, so it's a function of one argument, and it takes the function takes the truth value of this WIF, the WIF to be negated, to the opposite truth value. That is, if A is true, then not A, negation A is false, and if A is false, then negation A is true. And it's similarly the case with these other connectives up here. Let's take a look at how these work. A implies B. A conjoined with B, A disjoined with B, and A mutually implies B. Let us take a look at how these connectives take the truth values of the whiffs A and B to the truth value for these whiffs. Now let's in each case here, I'll separate this off, write A and B truth values. A may be true and B may be true. It may be the cases that A is true and B is false. I'm writing out all the combinations, possible combinations here. A on the other hand may be false and B may be true, or A may be false and B may be false. So we have A implies B. If A here on this line is true and B is true, then what about the truth value of this whiff? And I'll write it just under the connective. Well, in that case, the truth value of this whiff becomes true. And what about if A is true but B is false? A implies B. Well, we have A, it implies the truth of, in parentheses, B, but on the other hand, B is false. So under those circumstances, false. And under the remaining two circumstances, the falsity of A, the truth of B, that whiff nevertheless is true, and where both are false, that is true. Now, I could go through and I could describe some English sentences using the word imply and substituting for A and B here some simple propositions in English, and I could show you why intuitively these make sense, but I'm not going to do that. I'm simply going to state as a fact that that is the truth value of the whiff A implies B under the various ascriptions that we have here of truth or falsity to the whiffs A and B. And I'm going to do the same here. A and B, true, true. Well, we have both A and B in that case. The whiff is true, false under all other circumstances, ascriptions that is of truth and falsity to these whiffs A and B. A or B, well, so long as one of them is takes the value of true over here, then this whiff is true. They do here, here, and here. Here, however, they both take the value false, and so that is false. A mutually implies B. Well, A implies B and B implies A. Under these circumstances, A does indeed imply B. Does B imply A? Well, they're both true. Yes, it does over here. A implies B. No, it does not. So that is false. Does B imply A under these circumstances? True and false? No, it doesn't. So that is false. Where they're both false, that comes out as true. Now I'm going to simply stipulate these, and we describe these as truth tables. You've doubtless heard that expression. You may well have come across them in the logic classes that you've taken thus far.